about using PowerShell to help you reverse engineer. A little bit about myself. If you're wondering my last talk, I'm a security guy by trade. I'm a malware reverse engineer at Ambient, former Navy, former contractor with the U.S. Army Red Team. I think PowerShell is a great tool for hackers, and I'm the creator of PowerSploit, which is a module used for both reverse engineers and pen testers. So all the malware that I'm going to be talking about and the code that I use to analyze that malware, I'll provide to you. Just get with me afterwards if you're interested. Also, the two malware samples that I'll be demonstrating today, I downloaded from a site called VirusShare. It's an invite-only thing, so if you have a friend who happens to have an account, have them hook you up, and you can download some pretty cool malware.
Or visit some websites.
Yeah. or visit some very shady websites.
Exactly.
Yep. Okay, so what is reverse engineering? Well, there's kind of like two definitions. There's the more generic definition, which is the dissection of any finished product for which you don't have like the original specifications, and with the goal of uncovering how it ultimately works. As it's applied to software, that would refer to the process of analyzing any compiled code in order to figure out how it works at a semantic level. So there's different types of software reverse engineering. Static reverse engineering, which is analyzing compiled executable without actually running it, and dynamic software, RE, which is analyzing it by running it. Most often you'll use both in conjunction when reverse engineering a sample. So a good example of a static reverse engineering tool would be like IDA Pro. So if you want to analyze a compiled binary, that's a great tool for doing static analysis where you're not executing it. An awesome tool for doing dynamic analysis, so analyzing it while it runs, is really any debugger. My favorite debugger for analyzing native code is WinDebug. All right. So why use PowerShell as a reverse engineering tool? Well, I personally think it's ideal for automating the reverse engineering .NET assemblies. And the reason for that is, well, PowerShell is a .NET interpreter. And within .NET, you have access to a massive API, specifically the reflection API. So the reflection API allows you to perform all kinds of cool type introspection. So you can feed PowerShell an arbitrary .NET executable, and you can ask a ton of questions. Tell me all of the namespaces in that executable, all the classes, all the methods. You can even go so far as to ask, like, okay, how is each method implemented? Like, what are the actual like bytecodes that implement that method? So you can ask all those questions and get all the answers within PowerShell for if you're interested in analyzing a .NET assembly. PowerShell is also really handy if you want to interface with lower level functions and, like, say, in the Win32 API. It's not the easiest thing to do in the world. Probably the easiest way to do it is to use add type and compile C# code inline in order to interface, say, with a function in kernel 32. There's multiple different ways to do that, but the fact that you can interface with those lower level APIs in PowerShell is pretty cool. So why else would you use PowerShell as a reverse engineering tool? Well, why not? Like, there's a ton of existing RE tools written in Python, so let's do that in PowerShell as well. All right, PowerShell is just an arrow in your quiver. It is just another tool to aid you in reverse engineering. There's just a wealth of tools out there that you would benefit from using if you're going to reverse engineer anything. So if you're doing dynamic analysis, you're going to need a good debugger. I recommend WinDebug. You need a safe execution environment, so a VM, Hyper-V, VMware. For static analysis, for disassembling or decompiling code. There's some great tools out there. One of my favorites for decompiling .NET executables is ILSpy, which is basically the free version of .NET Reflector. And there's IDA Pro. That's a commercial tool. It's several $1,000s, but there's a free version as well. It's just a little more limited. Sometimes when you're doing dynamic analysis, like you want to run that, say, like a malicious executable and see how it interfaces with the operating system. And that's what sandboxes are really good for. So this one out there is called Cuckoo. It traces like all API calls that your sample makes to the operating system, and will print that out in a nice report. So you can get like a high-level overview of what the capabilities of a piece of malware are just by running it in this sandbox. Now, it's not going to work every time because, I mean, malware authors are onto this, and they develop techniques to get around sandbox analysis all the time, as well as dynamic analysis. So there's hundreds of anti-debugger techniques that are out there. So you need to be aware of those when you're analyzing the sample. And then just a good old hex editor is your friend as well. All right, so today we're going to be doing two things. We're going to look at two different malware samples. They're both .NET malware samples. And again, the reason being PowerShell is very useful for analyzing .NET samples. The first sample is mass malware I downloaded. I thought it was pretty cool because, as you'll see, it has a bunch. It has 2 executables embedded inside of it, and each executable is obfuscated and encoded using various techniques. So, like, they're actively preventing someone like me from trying to RE it. The next sample is Syrian malware. Supposedly it was state-sponsored, so it's kind of an interesting backdoor, and it uses string obfuscation, and I'm going to show how we can use PowerShell to automate deobfuscating every string in that assembly. So with that, I'm just going to jump right into it. So here I'm in my VM that doesn't have any network connectivity. It's a good thing. And the first thing we're going to look at is this mass malware. This sample turns out it's both a Bitcoin miner and a DDoS tool, a distributed denial of service tool. So here I just threw it into my favorite .NET decompiler, ILSpy, and we can look at some of the assembly attributes here. So, you know, someone doesn't want me looking at this, apparently. all the more reason for me to, take an interest in this one sample. So here it tells me what the entry point of this executable is. It's the main method, as it usually will be. So here I could just click on that main method, and it'll go in and decompile it for me. It takes a few seconds because the main method is huge. So here we have this. Can everyone see this? Yeah. Okay. So it's defining this massive byte array. I have no idea what this does at this point, but it's pretty large. And so it saves that to the data variable, which gets passed into this function here, along with this long string. So I still have no idea what that does, but I'm curious and I want to start digging into it. So you'll notice one of the things that it does here is it takes that string and converts it into a byte array before passing it to the stop method. So I can click on that and see what's happening here. So it's taking that string as well as that massive byte array, and it's using the XOR operator to decode this encoded assembly or executable. And how do I know it's an executable? Is because it's decoding every byte, and then it's then taking the data array and passing it to assembly load. So the assembly class, it's system.reflection.assembly. That class has a static load method, which is extremely useful for an attacker. It will take a byte array of any .NET executable, read it in, and load it in memory. So what we have here, just by very quickly analyzing this, is we have an embedded XOR encoded .NET assembly. Question in the back?
Yeah, is there any risk to loading this in ILSpy, or is it just like a reflection only loader?
Okay, yeah, the question was, is there any risk in just throwing this into ILSpy? And no, it does load it in basically a reflection only context. So yeah, it won't execute anything just by the mere fact of you loading it in here. Good question. Okay, so what I want to do in PowerShell is a few things. I want to go back to the main method here. I want to extract that huge byte array and then pull out this string here. So I want both those things. And then I want to implement the logic right here. So I mean, that's just a really simple for loop. So once I've extracted both those things out of the assembly, then I can just throw it into this for loop. And then I can, once those bytes have been decoded, I can write those out to disk. And now I have another executable to analyze. Okay, so the first thing we're going to do is we're going to take the first executable, read it in as a byte array, and load it. Okay, so now that it's loaded, I can start doing that type introspection on that assembly. I can ask, what classes do you have? What methods have you implemented? I'm interested in learning more about the main method, the entry point of this executable that contains the byte array and that string that I want to extract. So I wrote a simple .NET method disassembler. It's in PowerSploit. It's called getILDisassembly. And so I'm taking my assembly object and asking for the entry point of it, which is that main method. And then I'm going to pipe it to getILDisassembly to disassemble the Microsoft Intermediate Language opcodes that implement that function. So here are, what a .NET decompiler will do is it will read these opcode instructions and then convert it back into like C# syntax. But here I'm interested in the low-level details because I'm going to show you in a minute, like I need some of this low-level stuff in order to pull some things out. So the first thing here is this LD token instruction, and its operand is this thing here, which is our byte array. So if I go back into the main method, this byte array is implemented, where is it? I forget where exactly it's implemented, but the gist of it is, in order for me to pull this out, I have to replicate this functionality here. So I need to get a reference to this field, the ECAC53 field, and then I need to pass that field to this method, this array initializer. So in order to do that, I need a couple things. So specifically, I'm interested in the metadata token for these items. So when you're writing C# code, if you want to call a method, the way you call it is by name. So if I want to call like the initialize array method, I would type initialize array, provide the parameters to it, and execute it. I can't do that now. The initialize array method it's an internal, like non-public method. So in order for me to pull that out and actually execute it, the easiest way to do that is with its metadata token, which is like the numeric equivalent of any member in .NET. So with those metadata tokens, I can pull out this array, the method that I need to call to initialize that array, as well as I can reference a metadata token of the string that I need as well. So here's the byte array, the metadata token, and I have it here in its hexadecimal representation. So these are the three metadata tokens I'm interested in: the array itself, the class, the method that initializes that array, and then that XOR key array string metadata token. Now with those, I can get references to all of those items. And the way you do that is through your assembly, you get the module in that assembly, and then you call resolve field, resolve method, resolve string, and you give it that metadata token, and then it'll give you access to start messing around with those things. Okay. Cool. Okay, so now if I look at the XOR key array string, there, I have it right there. So I effectively extracted that out of the executable. Now, I don't have access to the array field yet because I haven't initialized it. So let's look at the array initializer method and see what parameters it takes. So it takes an array and a runtime field handle. And I think I have the runtime field handle already. And it's in the byte array field object. Okay. So yeah, the field that I extracted does have a field handle attribute. I don't really know what it does, but I'm just going to give the method what it wants, and hopefully it'll all work out. So again, that method wanted a byte array, and here I'm creating a byte array of the size of the array in the executable. So now if everything works out, I will give the initializer method what it wants. Okay, and hopefully now my byte array, is populated with the encoded executable. So now between that and that string that's used to decode this executable, I have what I need to decode everything. So here's my for loop that does that. So it takes the array, and for each byte in that array, it uses that string as an XOR key. So it just increments through that XOR key string. So like the first character of that XOR key string is used to decode the first byte in our huge array, and so on and so forth. So I'll run that. I think I forgot something. Oh yeah, I forgot to take that XOR key string and convert it to a byte array. Cool. So hopefully it decoded. Let me look at the first 2 bytes, and I'll print them out in hexadecimal. Okay, those first 2 bytes really stand out to me. 45A. The ASCII equivalent of that is MZ, which is a PE header. So, quick trivia, does anyone know what MZ
Mark
means?
Spinski.
Say again?
Mark Spinski.
Mark Spikowski? Yep.
Okay. I met him.
Yep. Yeah, you got it. Cool. So, yeah, it looks like everything decoded. Now let me write it out to disk. And now I have my next executable to analyze. Cool. Okay, now let's continue to go down this rabbit hole. Okay, so here's our new executable. This one appears to be obfuscated with Obfuscator. No big deal. There's some really good tools out there to help you out with this. My favorite is called D4 Dot. It's like general deobfuscation utility. It supports I think between like 8 to 10 different .NET obfuscators. It works really well. So I'm going to run that through D4 Dot. And then after that, it'll allow me to more easily analyze it. So let's just start digging into this. At this point, I have no idea what this does. So really, I would just start by browsing around. First thing I may want to do is look at the entry point of it, so the main method. And okay. I could dig into this a little bit. At this point, I still don't really know what it does, so I would just, start clicking around, checking stuff out. And when I was going through this, this kind of stood out to me. We're decoding a Base64 encoded string, and the reason that stands out to me is just because, usually you would use that to just as like a poor man's obfuscation. So let's check out what it's actually decoding, this string 0 here. Okay, so we got some random Base64 encoded stuff. Now what is it going to actually do to that once it Base64 decodes it? So it's going to pass that byte array to this method, retria, whatever. Okay, so it accepts this byte array, and then that byte array is passed to some more methods. No idea what they do, so I'll just click on them. Okay, so there's some bit manipulation that it's doing. Not even going to try to get into what's going on here. I mean, it looks kind of complicated to me. So I'll just keep digging around. And ultimately, what I found was I was tracing every time that byte array was used that started out as that Base64 encoded string, and it ultimately wound up here. So once it was decoded, it wrote all the bytes to disk, and then it started the process. So that tells me that this Base64 garbage was decoded and then manipulated in various different ways into a form that they could write to disk and actually execute. So this tells me that this is just another another embedded Russian doll, basically. So so far, I think all this does is it just hides another executable, which might actually contain the actual malicious payload. So let's automate this as well. Okay, so again, I'm going to take in my new executable, load it as a byte array, and then call the load method on it so I can start interacting with it. And now I'm going to get a reference to the retrieval K type. And the reason I want to do that is because, let's see, what does that do again? Okay, this class is the class that contains that Base64 encoded string that I need to extract from the assembly in order to do anything interesting with it. And then once I have the instance of that class, then I can start pulling out fields from it. And in particular, I'm interested in the string 0 field, which is the Base64 encoded string itself. And I'm going to pull the value out of that field. Okay, that looks like our guy. Now I'll convert it into a byte array, which is what it was expecting before it got passed on to the decoder method. Now the decoder method that I'm interested in is this one here, this retria, which is inside the retrieval E class. And I'll show you that again. So in the E class here, we have this